Hello everyone, today we are going to record another tutorial on ToDo dApp. This tutorial will cover the basic task management functionalities where users can create, delete and update certain tasks. The purpose of this particular task management ToDo dApp tutorial is to introduce users to the smart contract, focusing on the state management and the user interaction. We will cover this tutorial in 4 steps, where the first step will cover the setting up of the development environment. In the next step, we will develop the smart contract. And in the third step, we will deploy the developed smart contract on the aelf blockchain. And in the last step, we will develop the front end to interact with the deployed smart contract on the aelf blockchain. In the first step, let's set up the development environment. If you have already covered other tutorials on aelf blockchain, you must have already set up the development environment in your system. Now, if you haven't set up the development environment in your system, then we will go through this particular step one by one. Now, first we should have VS Code installed in our system. To go through this tutorial, you can click on this link and download the VS Code editor to install in your system. Then after that, we will install the required packages. First of them is the .NET 6 version. So we will click on this link and we can download and install based on the operating system we are using. I will check whether the .NET is already installed or not on my system, as we have covered the previous tutorials as well. So if it is already installed, then it will show me the version of the .NET. Then if it is showing the .NET version, it means it is already installed on my system. So I will skip this step and move to the next step. In the next step, I will install the aelf contract templates using the .NET command. I will copy the next command, that is .NET new, and with the install flag and aelf.contract templates, I will paste this command inside terminal. If aelf contract template is already installed, it will show me the message, and if it is not installed, then it will install, as it is showing that it was already installed and now it is replacing the version. In the next step, we will install the aelf deploy tool. Before moving to aelf deploy tool, aelf contract templates contains the various predefined templates for the ease of developing the smart contracts on the aelf blockchain. That's why we installed aelf contract templates in the last step. Now we will install the aelf deploy tool, which is required to deploy the smart contracts on the aelf blockchain. We will copy the next command, that is .NET tool install with a global flag. We will install it globally so that we can access this command from anywhere in the terminal from our system. So we will copy this command, paste inside terminal and press enter, and it will show that aelf.deploy is already installed on our system. In the next step, we will install the Node.js and Yarn. So first I can check the version because I have covered the previous tutorials. You can also check the Node version using the node-v command. If it shows you the version, then make sure that your version is greater than 20. So I can just switch the version using the nvm command, using nvm use version 20. You can also use nvm to switch the node version in your system. Now I am using node 20. I can check the version again. It is showing me node 20. Now I will check the yarn version in my system. If it is already installed, I will then again skip the step of the installation of yarn. As Node.js and yarn is already installed on my system, so I will skip this step. Now, if you are installing the aelf deploy tool for the first time, and if it is saying that it is not available, then you can uninstall and install the aelf deploy tool again. That is a note for you. Now we will have to install the aelf command. Aelf command is used to interact with the aelf blockchain. It will enable you to interact by creating a wallet or managing the transactions. So we will copy the next command. Using the npm, we will install the aelf command. So if a sudo keyword is written inside the terminal, you'll have to provide the password and then press enter. It will install aelf command in your system. After this step, we will finish the first step of setting up the development environment on our system. And if, let's say for example, certain permissions are not provided, then you will have to provide those permissions. That is using sudo, which we already have provided in this command. Now in the next step, we are going to develop the smart contract. Now the aelf command is getting installed on my system. Once it is installed, then we will start the development of the smart contract. Now it is showing that it was successfully installed and the aelf command is successfully installed. Now I will move to the next step of the development of the smart contract. I will start a new smart contract project. So the terminal is already open. So I will start this project inside a folder called aelf tutorials. So first I will change to that tutorial. I will go to desktop where I have created a tutorial for aelf tutorials. I will change my directory to aelf tutorials. Then I will create a new directory using mkdir command, which is used to create new directories or new folder inside our system. So I will use mkdir ToDo app is the folder name. So now I will change my directory to ToDo app, and then I will create a new sample using .NET new aelf command. So it will create a new project that is .NET that is called ToDo app. So I will copy the next command, that is .NET new aelf -n ToDo app. So it will create a new project that is ToDo app. When it is successfully created, we can see the folder. It will show you the source folder and the test folder. If the source folder and test folders are correctly shown in your terminal using the ls command, it means the last command worked successfully. Now we will start by writing the smart contract code. First, we will open our ToDo app in our VS Code editor. We will open this folder in the desktop. As we were working with aelf tutorials, we will go to ToDo app and then we will open this. This will show the directory structure. Here you can see inside source folder, there is a protobuf folder and then there are other files. Now I will check the next instructions. Now I will add the smart contract code. Now we'll have to develop the smart contract code. As we have already explained in the previous tutorials, as there is a proto file which is inside the protobuf folder which we just saw inside the directory. So now first let me explain the significance of this dApp, the decentralized application which we are creating. This dApp will allow the users to create a task, mark a particular task as completed, delete a task, selected task, and list all the tasks which are created by a user, and then edit a particular task which was already created. First, we will go inside the source directory and then we'll have to rename the hello world contract.proto file inside the protobuf contract folder to do app proto file. You can do this using the next terminal command, or you can directly go to VS Code, open the contract folder. There is a hello world contract.proto and you can directly rename that file to do app.proto. Make sure you use the correct name. It is todo_app.proto. To avoid the mistake, you can copy the name from here and then you can rename it here by giving the name to the file here. Now open this file. Here there is already pre-written code, but we'll have to change this code according to the ToDo app. Now in the proto file, we define all the RPC methods or RPC functions which will allow us to interact with the aelf blockchain. It means the RPC methods are used to write the data on the aelf blockchain or to get the data from the aelf blockchain. Then there are messages. You can call messages as events as well. So we will use certain messages for certain functions and we will use these messages to get the data about a particular function, or when a particular function is operating, then we will get certain data when a particular message is evoked. So when an event is emitted or a message is emitted, then we will see this information. So we will copy this code and we will select all the code inside which is already written and we will delete that, and then we will paste the new code that is related to ToDo dApp. And now you can see there are certain RPC methods. So one is the initialize method that actually initialize the smart contract. So these are only the definitions. These are not the implementations. So protobuf contains the definition of all the RPC methods and the messages, or you can say the events. So here there is an initialize method definition. Then there is a create task method definition, update task method definition, delete task method definition, and then list tasks, get tasks, and get initial status of the task definition. And then there are certain messages. One is task input, one is task update input, and one is task list. So now we have saved this proto file. So we will move to the next step. In the next step, we'll have to create a state file. Now state file is used to hold the variables that store the contracts data and make sure that this data is saved and accessible where the contract needs it. We will have to update this ToDo app state file. So we will go inside source folder and we will see there is a file called ToDo app state.cs, that is a C# file. So we will copy this code to maintain the state this file is used, and as you can see, this is ToDo app state.cs file. So we will select this code, we will again delete this code and we will paste the new code here and we will save the file. As you can see, there are certain states which are listed here. One is the initialized state, one is the owner state, one is the task state, and one is the task existence state, and task IDs and task counter states are some of the other states. So now we have saved the state of this particular ToDo app smart contract. Now in the next step, we will implement the functions which are initialized or which are defined inside the proto file. So we will now go to ToDo app.cs file. So this is our actual smart contract. So here we will implement all the functions. Here you can see how the initialize function is initialized or implemented. And here we initialize some variables or some values of, or you can say some states like initialized owner, task IDs, task counter, these state we initialize here. Then there is a create task function which is used to create the task in the to-do list. Then there is a update task function which is used to update that created task in the to-do list. In the next step, there is a delete task function which is used to delete the created task in this particular smart contract. And then there is a list task function. It means it will list all the tasks which are created. And then there is a get task function. It means it will get the detail of a particular task and it will also get the initial status of a particular task. So now what we need to do is we need to copy this smart contract code and we need to go to the ToDo app.cs file where code is already written. Again, we'll have to select that. We'll have to delete that first and we'll have to paste this new code which has the implementation of all the functions explained. Here you can see all those functions are listed. We'll save this file, initialize function, create task function, update task function, delete task function, and list all the task functions and get task function and get initial status function. Now, as we have completed our smart contract development, or you can say we have completed the implementation of all the functions of our smart contract. Now, we will build our smart contract first. We will check if there are any errors. So now we will copy the .NET build command, but this command should be run inside the source folder. So first we will copy this command, then we will go to our VS Code terminal, and then first again here also we need to check the node version. If it is 18, then you can change the version using npm use, and you can use the 20 version. It is nvm. Sorry. So now we will use this version. So now if we check the node version, so it is 20 now. So make sure your node version is 20 inside terminal before building the smart contract, and don't forget to change the folder to source folder. Once you are inside source folder, now you have copied a command that is .NET build, and we will build our smart contract from here. So this will build our smart contract, and outcome of this particular step is that it will create a bin folder, and inside that there is a debug and net6 folder, and we should get a .dll.pest file as an output. So this is the build created, and as we can see the message, the build was succeeded with a warning. We can ignore the warning here, and there is .test file, that is the outcome, and as we have gotten that already, so it means the step of building was successful. So now we have completed two steps where we have set up the development environment and we have completed the development of the smart contract, that is a ToDo dApp smart contract. As the smart contract is already created, so now we need to deploy that on the aelf blockchain. So we will go to step 3 where we will deploy our smart contract. So now here we will use aelf command. Aelf command is actually used to interact with the aelf blockchain. So to deploy the smart contract on any blockchain or on aelf blockchain in particular, you need to have a wallet, and we will create the wallet in the first step using the elf command. So we'll copy the elf command create, and we will paste this command inside terminal, which will create a new account for us. We will press Y here to create the account. So it is actually saving this particular information in a file. So we will provide the password to the file to encrypt that file with a password, and this information mnemonic, private key, public key and address. So account is actually associated with a public key and a private key, and mnemonic is a simple form of a private key, and address is a defined form of the public key, or you can say it is a shortened form so that we can easily recognize a particular address or particular private key as a user as well. So we cannot recognize another user's private key, but for us it is easy to remember instead of remembering the hex code. So now we have saved this information already in the file. So it means we have created the account. Now in the next step, we will first export the wallet address. So now it means we will set up an environment variable so that using this wallet address or wallet password, we can simply deploy the smart contract. Now, as we have two export command, one is for wallet address and one is for wallet password. So we will export these two environment variables. So first let's export the wallet address first. So we'll copy this command, we'll go to the terminal, and then we will paste this, and wallet address is the last address. So we will copy this address. So address is the last field. So we'll copy this from terminal and we will paste it here. So this is our wallet address. So now we will export this environment variable. In the next step, we can export the wallet password. So this is the password of the file which you created to save this particular information, which was created using elf command create. So now we will export the wallet password. So wallet password I gave for this was Mohit@123. So I will press enter. So now I have set up both the environment variables. Now in the next step, I need to have some funds to deploy a smart contract. We are actually doing a transaction on the blockchain. So it means it will require some fees, or you can say transaction cost, to deploy the smart contract or to interact with the smart contract when we are updating the data on the blockchain. So now we need to get that fund first. So we will use the faucet, that is a elf faucet, testnet faucet, which will actually get us some tokens. So now we will copy the next command to get us some tokens. We'll copy this command till the end. Don't forget to copy till end. And then we will go to the terminal and paste this command to get us some funds. It will simply give some elf tokens to my account, and if it says that a success is true, it means my account has some tokens, some elf tokens, and I can now check the balance of that. So here you will see another command, that is elf command call, and this address is the multi-token contract which actually manages the token on elf blockchain. The significance we have explained in the previous tutorials as well. And we have set the wallet address and wallet password already as an environment variable. And then this is the testnet network link, and we are calling the function, that is get balance, to get the balance of the elf token. So we will copy this. Now we'll have to enter the parameters. So the symbol of the elf token is aelf. So we will enter that, and then the owner is this address which we created using elf command create. So we will copy this address. This is the owner, and we will paste it here and press enter. And now it will call it and it will show some balance. If it is not 0 greater than 0, it means the faucet worked correctly, and the balance is 100 into 10 to power 8. So it means you have 100 elf tokens now. 10 to power 8, why I said? Because there are 8 decimals or precision of 8 decimals in the elf token. So now as your balance is 100 elf tokens. Now we'll deploy the smart contract. So first we will have to export another environment variable which we will use in the elf deploy command. So elf deploy command, as I explained earlier, is used to deploy the smart contract on the elf blockchain. As this environment variable is used, so we will copy this particular environment variable command that will export the environment variable, that is contract path, inside our terminal. So we will copy this command and paste it here. And now we will copy the elf deploy command. So don't forget to copy it till the end if you are selecting the text. If not, there is a copy icon. You can copy from here and then you can paste it in the terminal. It will deploy our smart contract on the elf blockchain. So now as you can see, this command is saying command not found elf deploy. If that happens, what you can do is you can uninstall the aelf deploy tool and then reinstall it again. So this problem might come up. So we can jump again to our first step, that is setting up your development environment. There we had a command to install the aelf deploy tool. We will copy that command again, and instead of install, we will uninstall it first. So let's uninstall this, and it was successfully uninstalled. And now we can again paste the command and will install the aelf deploy tool. So it will install the aelf deploy tool again. So if you face this issue, so you can do this. Now, before moving further, there is a condition written. So you need to export a path. So now it means you need to set another environment variable. So just copy this command and then paste it inside the same terminal, and then it will export another environment variable, that is path. So we are setting up the path for the aelf deploy tool. Now we can go back to our aelf deploy command, which we copied in the end of the third step. We can go again there. So this was the aelf deploy command, this one. So we can copy this command again, or you can go back in the terminal itself, and we will press enter. And now the deployment process starts. So what it will do is, it will first take the code of your smart contract that is written inside ToDo app.cs file, and other files as well. The proto file where the definitions are written, the state where states are managed, and it will take this whole code on the blockchain. It will store on the blockchain so that we can later interact with this code once it is successfully stored on the blockchain. So deployment means we are putting the smart contract code on the blockchain so that later on we can interact with the functions written inside the smart contract. It will take some time to deploy the smart contract. So once it is deployed, it will show you the successful message that this particular smart contract has been deployed. As you can see, this smart contract now has been deployed successfully, and you will again see an address here. So this address is the smart contract address. So don't confuse with the owner's address and the smart contract address, as this address was generated through aelf deploy command. So this is the ToDo app smart contract address. So author is the owner address. Okay. So now we will use this address in the next step. You can copy this here. So we'll have to set up another environment variable. We will copy this address and then export this contract address. This is an example given. We have another address. We will first copy the export command. We will go back to our terminal and we will export our contract address, and address field shows the contract address. We will paste it here and then we will press enter. It will set up another environment variable, that is contract address. Why we are doing it? We will use that information in the later stages, because we might require contract address variable later on if we interact through the command line. But now we have done the deployment of our smart contract on the aelf blockchain. Now we will interact with it in the next step. That is our fourth and final step. So in this fourth step, we are interacting only through the front end. If you want to interact with the aelf command, or you can say from the terminal or command line, so you can follow our lottery game tutorial where you will have to change certain function names. You can play around this ToDo app tutorial as well, and you can also interact using command line. But here we will show the demonstration using the front end. So now we will clone a repo that where a template is created or a sample is created for the front end, and then we will create the application which will interact with our deployed smart contract, which we just deployed on that blockchain. Now we will copy this command. We will clone this. So now first make sure that you go back to the aelf tutorials repo. Now if you do cd space dot dot, it will go to the parent folder, that is ToDo app folder. Again press the command. So now it will take you the aelf tutorials. So now what you can do is you can paste this git clone command again, and it will clone the sample of the ToDo dApp front end. Now we can either open it here, or we can open in the new window of the code editor. So now here there is another ToDo app and aelf samples, right? So this aelf samples we just cloned, right? So there are 3 applications inside. So we will just open it and we will only interact with the ToDo app. So these samples are created so that all our tutorials front end samples are at one place. So we will interact with the ToDo app. Here we are not interacting with the smart contract. That part we have already completed. So we will interact with the dApp. Now this is the dApp you will see. So this is the structure, and as you can see, this is the structure which is shown here, and now we can also see that structure here. Now, to run this particular front-end repo, or you can say to front-end application, we will have to install the necessary libraries or packages. So we will use npm install for that. So we can copy that, and we can open the terminal again inside the ToDo app, and make sure you'll have to go inside the front end of the ToDo, right? So first go to the terminal and check where your terminal is currently. So now change the directory to, as you are inside app sample, there is a folder called ToDo, and inside that there is another folder that is ToDo app. So change that folder to that, and then paste the npm install command. It will install the required libraries and packages, which will install all the packages or dependencies written here. So it will install all these. So we will wait for that to happen. There might be an error, so you can use sudo for that. So we will use sudo npm install for that. We'll have to press the password. Now, as we have entered the password, so we'll see whether the npm install works properly or not. So if it works properly, then it means that we will be able to install all the required packages and dependencies here. Let's wait for this step to complete. Now we will have to go through the setup of the front end tutorial through certain steps. Let me explain. To interact using front end, we should have a wallet called Portkey wallet. If you haven't installed this wallet, what you can do is you can go to the Chrome extension, that is a Portkey extension. You can search it, Portkey extension, Chrome extension. The first link is there. You can, now it is showing remove from Chrome because it is already installed. If it is not installed, then it will show add to Chrome. So you can add to the Chrome. We will check whether the npm install work correctly or not. It is still in progress. So now let me just explain the steps which we will do. So first step is we will install the Portkey wallet. That should be there to interact using a front end application. And then we will have to first configure it inside core, because the application and the Portkey wallet are different components, right? So we'll have to configure this Portkey wallet inside our application, that is our front end application. Then we will write the function to connect that wallet from the application to this Portkey extension. Okay, we will connect that wallet. Then we will write the functions inside the front end to create the task, to update a particular task, to, like you can say, initialize the contract, to delete a task, to update a task, something of that sort. And we'll have to create forms. Those things we will do. So here, as we have already installed successfully, so now we will move to our next step, that is configuring the Portkey provider. So now we'll have to go to the file that is inside source hooks folder, and the file name is use to do smart contract.ts. So we'll go inside this file and we will search for this step A command. Okay, and there is a function called fetch contract. Let's copy this function implementation already. This fetch contract actually fetches the provider. Provider means when we are interacting through a browser, it checks which providers are provided. Means like Portkey is a provider inside the browser, so it will fetch the Portkey provider from there. Now we will copy this code. We will go to source, then we will go to hooks, and then there is a use to do smart contract.ts file. So here we will go to step A. The definition is already written, but we will have to delete because we don't want to do the duplication. So in this step A, we have written the function to fetch the provider, to fetch the contract as well. There we fetch the Portkey provider, and based on that we will fetch the smart contract. But how do this particular function know that which smart contract to fetch, right? So we'll have to provide the address of our deployed smart contract, which we already had in our last step, right? So now we can open our other folder, that is our folder called ToDo app. Inside ToDo app, we had that smart contract address. So we will scroll up and we will see this smart contract address is there. We will copy this and we'll again go back to our front end code. I think I have opened a wrong file. So now here we need to paste our deployed smart contract address. We'll have to first remove the text and we'll paste our address here and we will save this file. So it means it will first fetch the provider based on the chain ID, that is TDVW, that is for the testnet of aelf blockchain. And then we are providing an address to fetch the smart contract. Here we are fetching the ToDo contract from the chain. So now we will move to the next step, that is to initialize and fetch the smart contract. So here we'll have to set up the hook, that is use effect hook. So we have set up a function, but we'll have to call this function using a hook, right? So that's why it can work with the front end. We will go to step B inside the same file. We will first copy this code and we will set up this hook, that is use effect hook. And then we will paste this code. So we have written a function that is a fetch contract, and then in this hook we will call this function that is a fetch contract function. You have to save this file. Please don't forget to save the file. Now this hook actually initialize and fetch the smart contract and will call the fetch contract function. Now we will configure the connect wallet functionality. So we have fetched these details already, the smart contract details and the provided details, but now we need to connect it together, right? Now we will go to source, then component, then layout. This folder, this header folder is there. Inside that there is an index file, and we'll have to find the step C there, where we will configure the port key provider. We will configure the wallet. This is a port key wallet, which will actually connect the wallet. In this step, show the wallet address and it will say whether it is successfully connected or not. So we'll copy this code. We will go inside this folder, that is source, component, layout and header. So source, then component, then layout, then header, then inside the header folder there is an index file. I will have to search for step C. So there is a step C, that is to connect the port key wallet. There is a incomplete implementation and we'll have to select that. Please make sure you don't do the duplication of the connect function. So this particular function connects you to the port key wallet, as I have explained just now. Now in the next step we will create the form to create the task. It will actually, like you can say, allow users to enter certain fields in the form. So we will implement the form now. So we'll go to step D. Inside source pages home folder there is an index file. So we'll first copy this and then we'll go inside source, then pages, and then there is a home and there is an index file where we need to search for step D. So you can search for step D and then we will select this form, and then there is an incomplete implementation of the form. We will select that and we will save this particular function implementation, which is a form, not function. This is actually variable which actually initiates the form. Now in the next step we will initialize the contract. What we will do is, now we called the contract from the blockchain. Now we need to initialize it inside our application. There should be an instance of the smart contract inside our application. We'll call the smart contract via this get initial status function. So we'll copy this. Now we'll have to go to step 1 inside which folder. We'll have to check that. We'll have to check the home, and then there is an index file. In the same file there is a step 1 where we will check is contract initialized function. Okay, so we'll go to step 1. We will see where the step 1 is implemented. So this is the step 1. We will select this incomplete implementation and we will paste the complete implementation here. So it will initialize the contract and we'll get the initial status of the contract. Please don't forget to save the file, then go to the next step. Now it is calling the get initial status function. Now let's initialize the smart contract. It means we will update the toast inside the front end, where we will call the initialize function, which is written inside the smart contract, right? If you remember, in the ToDo app.cs file there is an initialize function which actually initialize the smart contract. In aelf blockchain, before interacting with the smart contract, we first need to initialize the smart contract. So we will go to step 2. First we will copy this and then we will go to step 2 where we will we'll paste the implementation of the initialize function. Now, in the next step, we will create a new task, right? We will write the implementation of the creation of the task. It means it will call the create task function of the smart contract. What we will do is we will search for step 3 now, where we need to implement the create new task function. So we'll copy this. So and then it will send the data to the blockchain. So it is calling the function that is a create task function inside the smart contract, and then it will update the toast it will simply show you the notification once the task is created, and then it will handle the errors as well. So now let's search for step 3 inside our front end code. So here the step 3 is there, where the incomplete implementation is there. Avoid the duplication and implement the create task function here. Now in the next step, we will update the existing task. So now as we have created the task already, now we can update this task from the front end. So updating task means we are simply updating the data on the blockchain. So we will call the update task function of the smart contract. Here we will have to collect the data in an object form, and then we will call the smart contract where update task function is called. We will send a notification if it is successfully updated, and then we will handle the errors. So now we will have to go to step 4, where we'll have to update the existing task. So we'll go to step 4. Now we will search for step 4 here, and then we will update the complete implementation here, and we will save the file. In the next step, we will have to update the task status. So let's say, for example, if I have created a task, so I can mark it as completed as well, right? So from pending to completed, we will update the status. What it will do, it will again call the update task function, because it is updating this a particular field of a task, right? Again, it will call the smart contract with the update task function, where it will send the status, and after the successful status update, it will show us a notification and will handle the data. Here you can see there is a get function which is being called again and again, which actually gets all the created task data to us. We will implement this that function later on. First, let's complete the implementation of step 5. Let's search for step 5 inside our front end code, and we will paste this code here, and we will save the file. Now we have created the task, we have updated the task, and then we have updated the status of the task. Now we can delete the task or remove the task as well, right? So in this step, we will delete the task. So we will call the update task function inside a smart contract, which will change the status to deleted or removed, right? So now again, it will call the smart contract function, and then it will again show us the notification on successful completion, and it will handle the errors here. So we will go again, and we will search for the step 6, where we will implement the delete task functionality inside the front end. Now, in the next step, what we will do is we will configure the form. Now we need to submit this form, because the form is created, the function to, like you can say, send that data is also done, but now there should be a button to submit that, which is provided to the user on the front end application. So now we will handle that. So this on submit function will handle the functionality of submitting that action which the user is taking. So it will check certain conditions, whether the contract is initialized or not, whether the task is created or updated or not. Based on that, it will implement the handle submit form. So we'll search for the step 7, and we will implement the on submit function here. So now we will save this file. In the next step, we will have to fetch the tasks as well. As I was explaining, there is a function that is get to do data, which fetches all the created tasks as well, because user has created the task, user has called the smart contract, but now the user needs to fetch that data as well on the front end to see which all tasks are created, right? So it will again call the smart contract function, that is list all the tasks, right? List task function is there. So now it will call the function from the smart contract, it will get the data, and based on the current wallet address, that is the connected port key wallet address, so it will only show you the tasks which are associated with your wallet address only, and then it will handle certain errors. So I will copy this code sample, and then I will go to step 8. If you have noted, the step 8 is written at the top. So now I can search that as well. I have found that step 8 is written. So I will implement the get to do data function and I will save this file. Now we have fetched the data as well. So now we have implemented all the functions to initialize the smart contract, to configure the provider and then connect the wallet, then implementing all the functions like creation of the task, updation of the task, and then updating the status of the task, fetching all the tasks and removing all the tasks. So now we have implemented all the functionalities of the front end. So we will now run the application, our front end application. So npm run dev command is there. So we'll copy this command and we'll go to our terminal. Make sure you are inside 2-dev folder and then you just enter this command and then it will run the front end application inside. So if it shows that permission denied, so you can simply use sudo to, like, there are certain maybe node modules which requires your permission to create the directory. So you can use sudo permissions and then you can enter your password. It will successfully run the application on this. So now let's open this URL, that is localhost 5173, and it will show that our front end is running now. Our front end application is running. Here you can see a button called connect wallet and then all tasks are there. But there is no task because the wallet is not connected right now. So add new functionality is also disabled because we haven't connected a wallet. So now first we will connect our portkey wallet here. So we'll have to click on connect wallet. It will open the pop-up for our portkey wallet. So we will unlock that and it will ask us to connect. Now it is successfully connected. So as you can see the address of the portkey wallet here as well. Here if you will go inside your wallet and if you will see the details, then your wallet address is starting from 2ZER. Elf is just a prefix. So now 2ZER is your wallet address. Now let's create a task. So first let's add a new task. So let's say for example this task name is new tutorial task, for example. Then the description is task to explain the tutorial to do dApp tutorial. Then we can select the category. It is related to work. So we'll select the category. You can select the category based on your choices. And now we will create this task. So it will, what it will do is it will call the smart contract function that will be called through the portkey wallet. So we will click on this. It will open a pop-up inside the portkey wallet and will ask us to sign a transaction. We will sign this transaction and now this transaction will create a new task. Now we'll have to sign this and then it will take this data. Why it asks us to sign twice? Because first it called the initialize function in the smart contract. First signing was for that and then the second was to create the task. So here now you can see the task title, the description, when it was updated time, and then when it was created. So now what we can do is we can edit this, we can mark it as complete, we can remove it as well. So now let's first update it. So let's first edit it. So let's say for example this, I want to change this particular to do keyword. So I can change that and instead of new tutorial task I will call it tutorial task, for example. And now I'll have to call the update task function inside the smart contract. So that is why I'll have to again sign the transaction. So I will sign the transaction again and then it will call the smart contract and then we will sign the transaction. Now after this signing it will update the title and you can see the description as well. So it means we have successfully edited a task. So the default condition of a task is pending until we mark it as complete. As you can see the category is also listed here. We can now mark this task as completed. As you can see there is a pending tab. So it will also show here. Here you can see it was updated 90 seconds ago and it was created at that time. Now you can mark this task as complete. So it will again update the status, will again call the smart contract function. So we'll have to sign the transaction again. So we'll click there again and then it will mark the task as completed. So now as you can see the pending tasks are 0 now, and then inside the completed tab you will see one task and inside pending tab there are no tasks. So now we can remove this task as well. So now we will test the remove functionality also. So we will click on remove. It will again call the smart contract function to update the task, and then we will sign this. It will update the status, and now it will move from completed tab to removed tab. As you can see, the task has been removed. In the completed tab, there is no task now, and then there is another task inside the removed tab. So now we have successfully set up the front end where we configured our portkey wallet as well, set up the portkey wallet as well. We created a task by adding a new task after connecting the wallet. Then we edited the task, we marked that task as completed, and then we removed the task. So now if you will go through, this section will explain how you can connect to your portkey wallet. If you are setting up the portkey wallet as new, then it explains the functionality of connecting the wallet, and then how you can add a new task, then how you can update the task by editing it, and then how you can mark it as completed. Then after that, it will explain the functionality of removing the task as well. I have explained all these functionalities already. So now we have successfully completed the ToDo app tutorial. Congratulations, we have completed another step in the learning process of ToDo dApp tutorials on aelf blockchain, and it will give you a better understanding of how you can interact with the aelf blockchain smart contract. Stay tuned, keep learning with aelf blockchain, and keep deploying and adding more applications on aelf blockchain. There is a new AI chatbot which we just introduced, that is chat with aelf AI. So you can click on that and you can interact with aelf AI as well. So if you want to interact with aelf AI, you can learn more about aelf inside our chatbot as well. Thank you for tuning in for this tutorial, and stay tuned for more upcoming tutorials. Thank you.